Before electricity, before candles, before torches, there was a moment somewhere between 400,000 and 1 million years ago when a human ancestor picked up a burning branch and carried it somewhere. Not because they understood fire, not because they planned to use it, but because something in their brain said, "This is useful. Keep it." That moment changed everything. Not just for humans, for the entire planet. Fire is the reason you're alive today. It's the reason your brain is the size it is. It's the reason humans dominate every continent on Earth while every other large primate is endangered. But here's what most people get wrong about fire. Ancient humans didn't invent it. They couldn't. Fire existed long before humans did. In lightning strikes, in volcanic eruptions, in spontaneous combustion of dry grass. What ancient humans did was far more impressive. They learned to control something that had been trying to kill them for millions of years. And that process, from terrified prey avoiding wildfires to masters of controlled flame, took hundreds of thousands of years. And it happened in stages that most people never learn about. Stage 1 was the most basic. Ancient humans learned to not run away. For most of animal history, fire means one thing: danger. Every animal on Earth has an instinctive fear of fire. They smell smoke and they flee. This is correct behavior. Wildfires kill. But somewhere around 1 million years ago, something shifted in the ancestors of modern humans. Instead of fleeing every wildfire, they started following them. Why? Because wildfires leave something behind. Cooked animals. Animals caught in the fire, killed by smoke and heat, their meat already prepared. Ancient human ancestors discovered that the aftermath of a wildfire was a feast. Cooked meat was easier to chew, safer to eat, and provided more energy than raw meat. This is the first stage of the human relationship with fire: scavenging cooked food from natural fires. Not making fire, not controlling fire, just being brave enough to approach the smoldering aftermath and eat what was left. This seems small. It wasn't. Following fire instead of fleeing it was the first cognitive leap. The moment our ancestors began treating fire as a resource rather than a threat. And that shift in perception, that single change in how they thought about fire, set everything else in motion. Pause. Stage 2 was keeping fire alive. Imagine you found a burning branch left over from a lightning strike that ignited a dead tree. The branch is still burning. You've learned that fire is useful. It keeps predators away at night, it warms you, it cooks food. But you have no idea how to make fire. No one does yet. This burning branch is the only fire in hundreds of miles. What do? You carry it. Archaeological evidence suggests that ancient human groups, long before they could create fire, maintained living fires. They would transport burning material from one location to another. They would feed the flame to keep it alive. They would protect it from rain and wind. This required planning. It required cooperation. Someone had to be responsible for the fire while others hunted and gathered. It required the ability to think about future needs. The fire needs fuel now, or it will die tonight when we need it. Firekeeping was one of the first genuinely complex social roles in human history. The firekeeper was as essential as the hunter, maybe more essential. A group that lost their fire through accident, through rain, through neglect, was a group in serious danger. The pressure to maintain fire created new cognitive demands. And those demands over thousands of generations, changed the human brain. Stage 3 was the breakthrough that changed human biology forever: cooking food regularly. Here's a fact that most people find shocking. The human digestive system is too small for a raw food diet. Chimpanzees, our closest relatives, spend 5 to 6 hours per day chewing raw food. Their digestive tracts are massive relative to their body size. Their gut muscles are powerful enough to process raw plant fiber and uncooked meat. Modern humans cannot survive on a raw food diet. Our digestive systems are too small, our jaw muscles too weak, our teeth too flat. We are biologically dependent on cooking. This wasn't always true. The change happened gradually, over hundreds of thousands of years of regular cooking, as the human body adapted to pre-digested food. Cooked food is fundamentally different from raw food. Heat breaks down proteins. It kills pathogens. It releases nutrients that are locked inside raw food. A cooked sweet potato provides nearly twice the calories of a raw one. When ancient humans began cooking regularly, they got more energy from the same amount of food. That surplus energy went somewhere. It went to the brain. The change in brain size wasn't subtle. It was dramatic. 2 million years ago, the ancestor of modern humans, Homo habilis, had a brain of about 600 cubic centimeters, roughly the size of a large orange. By 300,000 years ago, Homo sapiens had emerged with a brain averaging 1,350 cubic centimeters, more than double. This expansion happened in parallel with the development of fire use. The correlation is not coincidence. Researchers who study human evolution now largely agree. Cooking is what made the modern human brain possible. But fire didn't just grow the brain, it restructured the day. Before cooking, ancient humans spent most of their waking hours eating, chewing, and digesting. Like all other primates, food processing was a full-time occupation. A chimpanzee in the wild spends roughly a third of its day chewing. Cooking collapsed that time. A meal that would have taken hours to eat raw could be eaten in minutes when cooked. Suddenly, ancient humans had something unprecedented: free time. Free time is not trivial. Free time is when you talk, think, plan, tell stories, build tools, solve problems, create. Free time is the foundation of culture. Every human achievement, language, art, technology, civilization, required time that wasn't consumed by eating. Cooking created that time. Fire gave it to us. Pause. Stage 4 was the revolution, making fire on demand. The exact moment when humans first created fire, rather than maintaining or scavenging it, is genuinely unknown. The evidence is hard to preserve. But by 100,000 years ago, there is strong archaeological evidence of fire-making tools: flint strikers, bow drills, hand drills. The bow drill is worth understanding because it reveals something important about ancient human intelligence. A bow drill works like this. A string is wrapped around a vertical wooden spindle. The bow is moved back and forth, spinning the spindle rapidly against a wooden board. Friction generates heat. The heat creates an ember. The ember is transferred to dry tinder and blown into flame. This process requires knowledge of at least a dozen variables: the right wood species for the spindle, the right wood species for the board, the correct technique, the right pressure, the right tinder material, the right moisture level in all materials. It cannot be discovered by accident. It requires systematic experimentation, knowledge transfer across generations, and the ability to understand invisible causation. That invisible friction creates invisible heat,
that creates visible fire. The invention of fire-making was one of the greatest intellectual achievements in human history. And it happened tens of thousands of years before writing, before mathematics, before any technology we typically associate with intelligence.
Fire did one more thing that almost never gets mentioned. It changed the night. Before fire, darkness meant danger. Predators hunted at night. The safest behavior after dark was to be still, silent, hidden. Ancient humans without fire were prey animals after sunset. Fire ended that. A controlled fire at the center of a camp created something that had never existed in nature before: a safe zone after dark. Predators avoid fire. The light extended the usable hours of the day. The warmth allowed sleep in colder temperatures. And around that fire, something extraordinary began to happen. Ancient humans gathered. They sat together in the light. They talked. Researchers who study the evolution of language believe that firelight gatherings, the first campfires, were where human language became complex. Before fire, communication needed to be functional: danger, food, movement. Around the fire at night, with no immediate task, communication became something else: stories, memory, imagination, the future, the past, meaning. The campfire is where humanity happened. Not in a sudden leap, not in a single invention, but slowly, over hundreds of thousands of nights, sitting in the light that kept the darkness back. We still do it: sit around fires, tell stories. Something in the human brain responds to firelight in a way it doesn't respond to any other light source. Studies show that blood pressure drops around open flames. Attention softens. People talk more, listen more, connect more. That response isn't cultural. It's biological. It's ancient. It's the memory of every campfire our ancestors ever sat around.